Right now, at the National Supercomputing Facility for Wales, up to 1,000 million operations are being processed every second. 2 hubs at Cardiff and Swansea, with thousands of computing cores, are enabling researchers to simulate and model the physical world through software, analyse large data sets, and perform complex calculations that would take years to process on a desktop computer. This is Supercomputing Wales. Part funded by the European Regional Development Fund through the Welsh Government, it's a unique collaboration between Cardiff, Swansea, Bangor and Aberystwyth universities. It provides an innovative, state-of-the-art supercomputing and big data facility for Wales. By working with our research software engineers and technical staff, academic researchers and industry partners are able to carry out a wide range of research that has a real impact on the world around us. The facilities are helping Cardiff University to advance cutting-edge research that improves understanding, diagnosis and treatment of a range of inherited diseases and cancer. At Swansea University, researchers use the facilities to study the nature of the universe at the smallest scales, including its behaviour in the first seconds after the Big Bang. Researchers at Bangor University are utilising the facilities to support tidal energy and oceanographic projects, collecting and analysing data to help create a more sustainable marine energy industry. At Aberystwyth University, the facilities are used to support the big data challenges of Earth observations, using high-performance computing to analyse satellite imagery and assess land cover and vegetation. Supercomputing Wales facilitates world-class research that will change our lives for the better. Visit our website to find out more and inquire about working with us on collaborative projects.
Hello everybody and welcome to Supercomputing Wales. A few of us from the team are going to tell you a little bit about who we are and what we do. First up is our academic director, Professor Roger Whittaker of Cardiff University. Thanks, Roger.
Thanks, Kath. On behalf of the consortium, thank you very much for joining this talk today. We're a national facility for research and innovation in Wales, a combination of universities, Aberystwyth, Bangor, Swansea and Cardiff University. This is a £16 million programme and we've been funded between 2016 and 2021 and we're now pursuing an extension to that to 2022. Our facilities represent 25,000 cores, roughly speaking, and we have a team of 14 research software engineers. It gives us a combined capacity to innovate and optimize code on the hardware. We've got resources of approximately 1 petaflop, and we also reach out to training. We are closely connected to the AICDT in Wales that hosts 55 PhD students. So our USP and approach, we're very much a community, not just a facility, and we're supporting a breadth of interests in Wales. We're here to really build a much stronger research, innovation and development environment for Wales. And this means that we're keen to embed training. It's one of the reasons why we're heavily involved with the AICDT, hosted out of Swansea University, involving all our partners. And early career research development is also a key aspect of the programme. We support a team of 14 research software engineering posts. These work as a cohort across our 4 institutions, and they also make sure that we have efficient resource utilisation on the system. So looking at Wales as a whole, the Supercomputing Wales facilities effectively represents a platform across 4 pillars that are of major importance to research and innovation in Wales. So health and life sciences, the low carbon energy and environment agenda, engineering and materials, including the semiconductor work and hub that's based in Newport, and also the ICT and digital economy space as well. We started off in 2016 developing our approach. We've moved from procurement, onboarding research software engineers to developing the service, and we're now at the point where we're pushing forward with our research and innovation ideas and grant capture and further investment. The supercomputing facilities are heavily used. We've been very pleased with the uptake of the service, and as you can see here, it's going from strength to strength on a monthly basis, and we've got high demand continuing, reaching about 16 million core hours at the moment on a monthly basis. So in terms of key projects, a number of areas are really important: materials and mechanics. The earth sciences and space agenda is also very important, not least for the Gravitational Waves Consortium, of which we support. The doctoral training is another important element. And finally, very relevant to recent events, the facility has been central to work on COVID-19 in Wales, which you'll hear more about shortly. So thank you very much for your attention, and I'll hand back to Kath.
Thanks very much, Roger. That's great. Okay, so now we've heard a little bit about what Supercomputing Wales is. I'm going to hand over to my colleague, Dr. Aid Fewings of the Bangor University, who's our lead technical engineer. So over to you, Aid, to tell us a bit more about our HPC facilities.
Thanks, Kath. And it's my pleasure to do so. Just to talk about the technical kit that we have. And the Supercomputing Wales systems really started back in 2018 now, when a partnership of Dell and Atos won the contract to supply two large clusters based on Intel Skylake Xeon Gold processors at the time. And those were delivered in Dell PowerEdge C6420 servers, plus also some NVIDIA GPUs delivered in Dell PowerEdge R740s. And overall, between the two systems, which we call Hawk and Sunbird, there was a total of some almost 14,000 processor cores at that time. They were all backed by a Mellanox InfiniBand fabric based on the EDR technology at that time, and in a 2-to-1 blocking configuration, and also supported by both Lustre and NFS storage solutions on various combinations of Dell R640, 740 servers and PowerVault storage arrays. And from users' perspective, this was all presented from a software layer that was fronted by Slurm, and there's some homegrown web portal technology that enables partners and users and researchers from across the 4 institutions in Wales to have a similar or almost identical access and minimal barrier to getting access to the systems. Behind the scenes, we use things like Ansible and Mellanox's OFED stack to deliver this, but that stuff sits with us in the technical team. Now, since 2018, the systems have grown quite significantly in a number of distinct phases. This is through things like researcher-funded specific additions, so where researchers have their own money to plug in some of their own equipment, which is dedicated to them, and also through some core additions as well. And the key things that have happened really there have been a significant expansion in the amount of GPU capability, again, delivered through Dell PowerEdge R740s with NVIDIA GPUs based on V100 and even A100 technology more lately, but also a slight diversification with the inclusion of AMD EPYC Rome technology based on PowerEdge C6525 servers, delivering significant performance benefits as we moved into 2020 as part of the core service. And also because everything moves on, the InfiniBand fabric of the Hawk supercomputer at this point was extended with some HDR technology, so up to 200 gigabits per second new technology as a second fabric for the system amongst all of the new servers to support things. So that works. That's very good, and overall it represents a growth of just more than 20,000 CPU cores now in the systems, plus significantly more GPUs at well over 60 GPU-based servers of varying configurations. And what this is laid the base for is a service that has maintained the core user interface that users get to use and is consistent, and nobody gets scared away by it being irregular or something a bit scary, but also allowed that to be developed with new services such as new types of user interface based around things like Jupyter and Jupyter Hub, and the open on-demand technology that enables access to these things in a nice web portal type approach. And enables our users who are both skilled and less skilled access to what is now a very large application stack encompassing hundreds of different applications across a wide variety of themes and disciplines. And so users have of multiple levels can access these things. And this is all delivered really because of the integration, or at least the good working relationship and partnership that exists between the technical and RSE teams, which I think has always been the key to Supercomputing Wales, having those people to deliver the real services in a connected and user-facing way. Thank you very much.
Thanks, Aid. So that was a really good overview of the technical side of things for us. And Aid made a really good point there that one of the things that we really take pride in is supporting researchers who have perhaps not so much technical skills or understanding or ability with software. And that's where our research software engineers come in. So next we're going to hear from Professor Biagio Lucchini of Swansea University, who's going to tell us a little bit about some work that's been done in the last year and a half or so in relation to modelling the spread of COVID-19 in Wales, which is a project that our research software engineers have played a really key role in. So over to you, Biagio. Thank you.
So thank you, Kat. As you say, I'm going to show a project now where it's the contribution of research software engineer has been key, and also the contribution to our society has been key, especially in Wales. So the project has to do with the modeling of the pandemic of COVID-19 in Wales. The part that we did has to do with the forecast, essentially, or if you wish, with the production of scenarios on how the virus and the epidemic are going to affect Wales at various stages. This is a project that involves epidemiologists, of course, because you have to understand the dynamics of the virus, but it also involves heavily mathematicians like me, and involves research software engineers who have been a key enabler for the project to run timely, since in order to produce a scenario that is usable to inform the policy, as it has been the case in our modeling, where our data has been used to inform Welsh government policies, it is important that everything in the modeling happens in a timely fashion. So the support of Supercomputing Wales from the hardware point of view and from the research software engineers in order to enable the programs to run on this hardware has really been fundamental and crucial. So here I'd like to provide an example of what we do. So we received the data from official sources like government sources. This is an example on the epidemic on May 2020, around May 2020, the few months earlier and later. And these are the data that we receive. These are the oscillations that you can see in red. So what we do is we prepare a mathematical model which with inputs that are aimed at reproduce the data, and these are the black points that you can see, will then forecast the epidemics all the way to, in this case, to July 2021. So we have had more than 1 year of predictions and forecasting, which is based on the existence of those data and on our ability to put them on supercomputing. So at this stage, we can model the various bands in the population and how they react and the various age groups to COVID-19. And this is what gives us the curve that we could cross-check with the data. And this will enable us to decide, or better, to predict what will be the various effects of government policies on the spread, or better, on the prevention of the spread of the disease. So having shown one of the typical scenarios that we work out under reasonable assumptions, here is what the model has done so far. So one of the first results was to build a reasonable worst case scenario, where reasonable worst case means having a clear idea of what is going on under reasonable assumptions in a case in which these assumptions actually could be verified in reality, even if they are on the pessimistic side. Our reasonable worst case has been used in various settings, for instance, to plan ambulance service response and to plan the health board provision of beds in ICUs. Then moving forward, when things looked better after we advised on the effect of lockdown and fire breaks in December, the scenario has been used for stage reopening of our society. And one of our latest results was an early warning of a summer wave that unfortunately, of which unfortunately we are still seeing the effects. What we are doing at the moment is to see the estimate on the isolation of teenagers and to see what will happen as the epidemic progresses through further stages. So Supercomputing Wales and the work that research software engineers have done on the model, as I said at the beginning, have been important and keep being important as we go through the various stages of the COVID-19 epidemic. And they still keep informing Welsh government response. So thank you very much, and I'm back to you, Kate.
Okay, thanks very much, Biagio. Finally, we're going to wrap up then from hearing from one of our research software engineers, Dr. Anna Price, who's based at Cardiff University, and she's going to tell us a little about the work that she's been doing in relation to the pandemic. Okay, thanks, Anna.
Thanks, Kath. So to give some background, my work is dependent on the CogUK consortium, which was set up in response to the pandemic in the UK for the sequencing, analysis and storage of genomes of SARS-CoV-2. And there are hundreds of members of CogUK have been contributing across several UK research institutions, the UK Public Health agencies and several labs. And Cardiff University has been a key contributor to COG, and Supercomputing Wales has made up a large part of that contribution. So to date, we just surpassed 1 million genomes sequenced in the UK, which accounts for around a quarter of the globally publicly available genomes of SARS-CoV-2. So massive achievement that hundreds of people have been putting work into. So my work centers around the CogUK metadata. So for each sequence sample, there's a associated metadata. So for example, the date the sample's collected, the lineage of the sample, and broad regional information on where the sample was collected. So early on in the pandemic, one of the questions that we were interested in answering is, how does the pandemic in England affect the pandemic in Wales? Particularly, are there lineages of SARS-CoV-2 originating in England and being imported into Wales? So to look into this, I built a time series from the metadata for lineages in England and Wales that are common to both countries. And I looked at cross-correlation of the England and Wales time series for each lineage. And we found from this that it was highly likely that there were lineages being imported from England into Wales. And the converse is true as well, that there are lineages being imported from Wales into England, but probably to a much lesser extent. So this work has developed over time, and I've been looking at further investigating this relationship between the England and Wales time series. So I've been building vector autoregression and vector error correction models to forecast the short-term future growth in sequenced cases for lineages that are common to both countries. And we found that for lineages that are sort of reasonably well established, they've been present in both regions for a few weeks, these models tend to work pretty well. And what I've been doing is I've been bringing both these analyses together into a single code base called Covate. And the analysis that Covate does is completely automated, so no user input is required. It automates selection of a VAR or VECM model and selects all the parameters as well. So moving towards the first stable release of the code, and I think this is when things start to get really interesting, is we can have a scenario that every time metadata updates, we can trigger a run of Covate and get lots of interesting information out the other side, and have an almost sort of real-time analysis of what's happening in Wales. I say almost real-time because in reality there's a little lag in the metadata. But yeah, we can get lots of interesting information out the other side. And we can also use Covate and the CogUK metadata to look retrospectively back across the pandemic and see what's happening during different time periods. So there's a lot of useful data that we're generating. And so a lot of the work I've been doing and work that my colleagues at Cardiff and Public Health Wales have been doing has fed into Welsh Government's technical advisory group, and we also contributed to several reports that went to UK Government SAGE. So again, this is an example of research helping to inform government policy. Thank you very much.
That's fantastic, Anna. Thanks very much. And yours and Biagio's use case studies have been really great examples of how Supercomputing Wales and our team of RSEs are making a real difference in this very difficult time for the UK, Wales and the rest of the world. Okay, I think that's it from us for today. I'd like to take the opportunity to thank Dell for sponsoring this presentation. And also, if you'd like to contact us or learn a little bit more about what we do, you can take a look at our website, which is supercomputing.wales. Okay, thanks very much.